Friends, do you remember the massive ship from the movie Titanic? The one that left everyone in shock? But believe it or not, compared to today's supertankers, the Titanic would look like a small boat. The Titanic was about 270 meters long. Modern supertankers, on the other hand, can exceed 400 meters in length. And it's not just about size. These giants can carry nearly 2 million barrels of crude oil. But here's the scary part. These ships are basically floating bombs. A small mistake, and within seconds, a massive disaster could happen. So the big question is, why don't these ships easily capsize in the middle of the ocean? This is where incredible engineering comes in. At first, you might think these ships have one huge tank inside to store all that oil. But that's not true, because it would create something called the free surface effect. When liquid moves freely inside a large tank, it can shift the ship's balance and even cause it to tip over. To solve this, engineers divide the cargo into multiple smaller tanks. A typical supertanker has around 10 to 20 separate cargo tanks. This prevents the oil from sloshing around too much, keeping the ship stable. Now imagine this. What if the ship hits a massive iceberg or underwater rock and the hull gets damaged? Something like this actually happened during the Exxon Valdez oil spill. In 1989, a huge oil tanker ran aground in Alaska, spilling millions of liters of crude oil into the ocean. The Blue Sea turned into an environmental nightmare. Thick layers of oil blocked sunlight and oxygen, killing countless marine animals. To prevent such disasters, modern tankers are built with a double hull. This means there are two layers of walls, an outer hull and an inner one protecting the oil tanks. Even if the outer layer is damaged, the inner tank often remains safe. There's also something called a cofferdam, empty spaces between tanks that act like safety buffers. These prevent leaks from spreading and reduce the risk of dangerous chemical reactions. Another interesting challenge happens when the ship unloads its oil and becomes empty. It can become unstable because it's too light. To fix this, ships take in seawater, known as ballast water, to maintain balance. But this also creates a risk. Releasing that water in another country can spread harmful bacteria. So today, ballast water is treated before being discharged. One of the smartest safety systems is the inert gas system. Exhaust gases from the ship's engine are cleaned and cooled, reducing oxygen levels to about 2 to 4%. This gas is then pumped into the cargo tanks. With such low oxygen, even if a spark occurs, fire cannot ignite. Finally, let's talk about loading and unloading oil. On the ship's deck, you'll see a complex network of pipes called the manifold. During this process, balance is extremely important. If too much oil is loaded on one side, the ship could tilt dangerously, or even capsize. So as you can see, these massive oil tankers are not just huge, they are engineering masterpieces designed with advanced safety systems and precise planning. So guys, how did you like today's video? Let me know in the comments.